we're officially going to start. Volumes by a common cross-section. Here's the idea. If I tell you this sheet of paper here, it's a common cross-section. It's just one cross-section. Notice that the volume is, not very much, but if I keep on adding an infinite amount of cross-sections, then eventually you get a 3D shape like this. Obviously, this is just a rectangular prism, so it's not something fancy. You don't need calculus for this. But look at all these infinite cross-sections. Aren't they all the same size and shape? Now imagine they're all the same shape, but let's say that they all got smaller and smaller to form a rectangular pyramid. We can find the volume of this pyramid by integrating this common cross-section and adding an infinite amount of cross-sections. Does that kind of make sense to you guys? It's kind of like what
cross-section again?
Cross-section. Bam.
One of those.
And we're adding them all up. And if you add them all up, don't you get a volume?
Yeah. So how does that relate to integrated? Yeah, so how is that integrated?
To find an infinite amount if we're going to add an infinite amount of cross-sections, that's an integral.
Oh.
It's area times an infinite amount, like you're adding an infinite amount of cross-sections.
It's like the rectangles.
Correct. That's what this is right here. See, area cross-section, the A of x of k times your delta x, which in this case, this little thin slice is your delta x. And you're adding all those up, and it creates volume.
So in the case of this picture, the cross-section would be that thing right here.
Yeah, so in the case of this picture, the cross-section will be this right here, that flat edge, and you're adding all of them up. And adding them all up, it creates your volume there. What's up, Jarella?
Cross-sections can almost be regarded as like just the multiple layers.
Yes, but it has to be, you have to pretend everything's a cake. How can I slice it that I have a common cross-section no matter where I slice? Like if I have to continue, once you slice it a certain way, that's how you're going to slice it forever, because you want to keep that same shape. It might be different size, but the shape is the same.
Okay, so it's a cake. If you have circular cake, but then if you have circular cake and you have another layer smaller, but if you have a circular cake and another layer smaller, could you cross-section it this way?
Don't worry. You look, check it out. Let's do one together. I think this becomes easy once you start seeing visuals. And if you want to download a program to do this, I'll show you where to do it. On Delta Math, when you do it, it's going to show you like your cross sections and how it's going to look. So look at example 1. A mathematician has a paperweight made so that its base is the shape of the region between the x-axis and one arc of the curve y equals 2 sine x. So this is y equals 2 sine x. Are we still okay? Linear units in inches. Each cross-section cut perpendicular to the x-axis, and hence the xy plane, is a semicircle whose diameter runs from the x-axis to the curve. Okay, so what all that means, don't worry, and I'll show you a visual 3D model. So this is the base of this paperweight. This is the base of that paperweight, and coming out of the board are semicircles. So the biggest semicircle you have is right here. That's the biggest semicircle. And of course, that's your diameter, right? So as the diameter gets smaller, the semicircle gets smaller. So it kind of looks like a dome, but of course it's small, it's a paperweight. You fit in your hand. Let me show you how it looks with my 3D model here. So I went ahead this morning, right before you guys came in for 10 minutes. Here is y equals 2 sine x. Can you guys see that? Yes. And now check it out. I'm going to animate it. I'm going to go ahead and put cross sections that are, let me see if I remember. Intersections, integrated volume of revolution sections, semicircles. And okay, that should be 0. All right, guys, sorry about that. I should have had it already ready. 0, and then high at, where's that pi? Is that pi?
Yes.
Pi, P-I, and C solid. All right, there it is. All right, can I make it bigger? Okay, let me see if I can make this move around.
But like not just like that. Like it's like a seal.
Yeah, this is the base. I'm trying to make it move. Man, can I not make it move? Yeah, if I had the file. Yeah, that's why I was asking about the 3D printer. Darn it, I can't make it move. Animate. Buttons, view, axis. Okay. But I can't make it move. Darn it. I can if I, you know what, let me pause this video. Let me pause the recording. Okay, finally. All right, guys, here we go. They told me, and it's not even up there yet. They told me that each cross section is perpendicular to the x-axis, so that's why it's coming out of the board, but perpendicular to the x-axis. Sometimes it will be perpendicular to the y-axis, but right now, so the semicircles look like, I don't know, let me make a semicircle out of this. Let me cut this out. The semicircle looks like, here's a semicircle. Do you guys agree that's a semicircle? Yeah. So it's coming out like that.
Oh. But you have infinite.
And I have infinite amount. That's where that dome came from. So it's coming out. It's an infinite amount of them. Of course, the biggest one is right here, but it's just a whole bunch of them coming out of the board. An infinite amount. And how is this semicircle dictated? By the length of this curve, right? Like, well, the length from the top of that curve to that's going to be your diameter, and it's coming out of that. How do we fix it? Okay, so all you got to know, look how easy this is. All you got to do is integrate your cross sections. That's it, and that's how you find your volume. So, how do you find volume? Here's your formula. Volume is the integral of your cross sections. Why will this be volume? Well, think about it, guys. This is area. And if you're multiplying by that dx there, won't that give me volume? Yeah, I mean, obviously this volume is almost zero because it's pretty flat. But if you put a whole bunch of them together, then you get, I don't know, what do you want to call this? Like thickness?
Depthness.
Yeah, depthness or whatever. Does that make sense to you guys?
Yeah.
Okay, so that's what's happening here. So, let's see, what are my limits? From 0 all the way to?
Wait, so A of X is the area
of a common cross section. Yes, now they're all semicircles, right? So, let's see, how do we figure this out? What is my A of X? That's the hard part. What is the area of this common cross section? So here's I'm doing my best. Oh, look, here it is. Here it is. Here's that semicircle coming out of that board there. Do you guys see that? Okay, so how do I get, so first and foremost, you got to know geometry. What is area of a semicircle? Yeah, well, you can say 1/2 pi r squared or pi r squared over 2. Now that you did that geometry part, now can we write it with this calculus here in terms of this equation? Well, the diameter is the length from the top of this curve to the x-axis. So the diameter is nothing more than 2 sine x. Does everyone agree? Okay, so that's not my radius. My radius, I have to take that 2 sine x and I got to divide it by 2. So my radius is 2 sine x divided by 2. So my radius is sine x. Are we still okay? All right, so here we go. My area of that semicircle, I'm going to write it as pi times sine x close it squared divided by 2. Have I lost anyone? So here's how you're gonna make your volume integral. My volume is equal to, isn't this pi over 2 just a constant? Usually you want to take out constants. That's how they usually have it in the multiple choice as well. Pi over 2 integral from what to what? 0 to pi of sine x squared dx.
Do you want it as sine x squared or sine squared?
It doesn't matter. If you put the square, put it on the outside. If you put the square on after the n, make sure it's after the n. Oh wait, hold on, guys. Did I do everything correctly? My radius is sine x, pi r squared divided by 2. Yeah, I did everything right. The pi over 2 is in front of the integral because that's just a constant, so I just took it out. It's my area. You know what I mean? Type this into your calculator. Make sure you are in radian mode. These will probably be a calculator question. Take out your calculator, guys. Let me take out mine. Here it is. The best way to do it, guys, in my opinion, I would just type sine x on here. I would type sine x right here on y1. And then I'm going to do this. I'm going to go pi over 2, math number 9. Nope, number 9. 0 to pi. And I'm just going to put y1 squared. And there it is.
And so you would have this as a calculator question.
Yeah.
Solve this.
Yeah. If it comes out in the non-calculator part, sometimes they just say they just want the setup, and you'll see we're gonna have a lot of experience. Yes, ma'am. Yeah, that's for the whole solid, which is in this case it's a paperweight. And if they gave us density of the material that they use, we could calculate how much weight. So for those of you that know about AutoCAD, that tells you the weight and the density and all that, that's all programmed in, so you can see where calculus is being used in AutoCAD. 2.467. At least how many digits? At least 3. 2.467. If you want to put more, put more. And in this case, it would be cubic inches. How do you feel, guys? Okay, so all we're doing, we're not introducing any extreme U concept. You're finding a common cross section, and you're adding an infinite amount of cross sections to create volume. What's up?
We found the area of the semicircle by using the diameter, which is the biggest one.
Well, it doesn't matter. They're all the diameters are dictated by the curve 2 sine x.
Oh.
Because it's the distance from the x-axis to that top of that curve. So all the diameters are dictated by 2 sine x, and then I don't want diameter to calculate area. I need radius, so I divided it by 2.
Okay. So the 1/2 pi sine x squared, that gives you any of the, it gives you all of the things.
The 1/2 pi r squared gives you the area of a common cross section for any of them. Yeah. Now, if you tell me an x value, then you're finding the area at that specific x value. But if you don't put an x value in there, and then you put your integral symbols, then you're finding the area. You're finding the volume because you're adding up all the cross sections from 0 to pi. Does that make sense? Okay. All right, guys. Let's see if we can do another one. Look how awesome this one. Well, don't even read it yet. Just look at this picture. What does that look like to you? Yeah, I'm thinking of something very specific that I see every day, well, almost every day, when I look up.
The sky and
Every day.
It makes noise.
a megaphone.
This is just a tip of it. It's a very big machine.
Engine.
All right, I'll tell you guys, because maybe I'm being vague. To me, this looks like the front of an airplane, the cone of an airplane, the tip of an airplane. Do you guys see that? Well, yeah. I mean, it's an airplane that you see like when you go flying. Doesn't that look like the nose of an airplane? This whole thing, like this is they're showing you the cross section, but imagine an infinite amount of cross sections, and that looks like, I'm assuming that cone is filled and it's not empty, but that looks like that's solid part of that cone. Maybe there's radar stuff in there and they have equipment, so maybe it's not filled, maybe it's empty, but to me, this looks like a cone, but a full, like, you know what I mean? The cone of an airplane. Does that make sense to you guys? Okay, this is what we're finding. Let's read what they want us to do. Example 2. For A through D, find a formula for the area A of X of the cross sections of the solid that are perpendicular to the x-axis. Okay, they're telling me perpendicular to the x-axis. The solid lies between the planes perpendicular to the x-axis at x equals 0 to x equals 4. The cross sections perpendicular to the x-axis between these planes run from y equals negative square root of x to y equals square root of x. Okay, so here's what they're telling me, guys. They're telling me that I have this curve in the xy plane. Y equals square root of x, y equals negative square root of x. And that's the curve that they have here. And that this cross section right here that I'm doing in blue, that is this same one as this one. Does that make sense to you guys?
Yeah.
You have half the circle coming out of this, and you got the other half of the circle going into this. Cool? Yes, yes. They do a pretty good job with this visual. See, here's the x-axis, here's the y-axis. So here's my x-axis, here's the y-axis. This part right here is the square root of x. This one's the negative square root of x. They cheated and just wrote x equals y squared. But that's pretty much the same thing. Square root of x, negative square root of x, which if you turn the x equals y squared, right? And this part right here is this part right there. And it's coming, like, see this part that's out of the board? Or that part is coming out of the board like that.
Okay.
And then this part down here is going into the board.
Oh, so it makes that motion.
Yeah.
So, and that's at 4, the blue line is at 4. The part that's going in, does that make it, like, is it like negative, or is it just in?
You just say that it's going that way.
Oh, okay.
But we're still, all we're going to do is get a model to find the area of that
That's
section.
exactly all. Because if you look at where like the intersects of the line.
Yeah, it says, solid lies. Yeah, it's going
Yes. So
that's why I was like that.
here we go. All we're doing is finding my cross section. This is what we would integrate, but right now we're rookies. How do I find this cross section? Let's see. Is that a full circle?
Yeah.
It looks like it to me. Before I even start, I go to the side and I go, area of a circle is pi r squared. That's just from geometry. So then I come back and I go, okay, so I'm definitely going to have a pi. I need to know what my radius is. My radius is the distance, look, check it out, from the x-axis to the top of that curve. Well, on this curve here that I have 2D, it's this distance here in green. Does that make sense? Okay, so if I'm from the x-axis to the top of that curve, what curve is that? Square root of x. So that distance is just square root of x. I close it and I put a square on it.
Because if the other one is negative, it's just going to be positive.
Yeah, it'll turn it back to, it would be negative square root of x, but our square root is going to be. Huh? Oh, the distance dictated between the x-axis and the top of that curve, that's just the distance between here and here. That's just square root of x. Right? If it's x comma the y value is square root of x.
Oh, that makes
Right.
sense. Okay, yes.
X comma y, where y is square root of x.
Yeah. Okay.
Are we cool there, guys? Perfect. So if I square the square root, I just have pi x. And there it is. That's my area cross section. They're not asking me for the volume. Are they asking me for the volume? No, they're not asking me. But if they did ask me for the volume would be, they're not asking, guys, but I'm going to go ahead and write it in here. Pi integral 0 all the way to of x dx. If they were. How do we feel? Okay, let's go to the next one. Same curve. Let me go ahead and draw the 2D model. I have the same curve. Y equals square root of x, y equals negative square root of x. But these cross sections are what? Squares. So that's all I want is my cross section. So let me show you with color. There's a good one too if you have colored pencils, guys. From the x-axis to the top of that curve, that is this distance. From the x-axis to the bottom of that curve, that is this distance. Remember, these are all cross sections perpendicular to the x-axis. You have a square coming out of the board. The biggest square obviously being on this side of the curve there. Does that make sense? So,
It's just a square.
what is this total distance right here? You can say square root of x minus square root of x. Square root of x minus a negative square root of x. But it's just the same thing as saying what? Yes, which is, what I'm trying to do is find a side length, guys, so that's square. Area, okay, let's slow down, Geometry. Area of a squared is what? Or just say side squared. I'm looking for one of the sides. This one right here in blue and green. If I add them up, the distance between here and here, isn't that just square root of x again? So it's 2 square root of x. And it doesn't matter how you do it. 2 square root of x, and then what do I put on the outside? A square. And as for some of these, you are saying, because you guys are pretty good with with area, you're like, Chavez, but that top curve is square root of x, and that bottom curve is negative square root of x, and I did that UH quiz, and that UH quiz told me that it was square root of x minus that negative square root of x. Guys, it's the same thing. That square minus a negative, doesn't that turn to a positive? So it's the same thing. As long as you know, like, oh, they're symmetric on the x-axis, that's square root of x, you could double it, there it is. So there it is, 2 square root of x, and then that's just one of the sides. It's also coming out of the board, but it's coming out of the board the same distance. So 2 square root of x times 2 square root of x. Does that make sense to you guys? So my cross section is 4x. How are we feeling, guys? Perfect. Ooh, now we're going to get more complicated. The cross sections, and notice they didn't give you any images. Not that I didn't want to give you. It's that I didn't have any images for this one. The cross sections are squares with diagonals in the xy plane. Okay, let's see if we can. Yeah. So look, draw a square. Oh, my square didn't come out. Awesome. And then draw a diagonal. That diagonal is, let me color code it, blue. So what am I trying to tell you about that diagonal? That diagonal is this, guys. That diagonal is this one. Does that make sense?
Oh, yeah, so they're triangles.
They're triangles coming out. You got a triangle coming out and a triangle going in. But it's still a square though. Does that make sense? Let me see.
Two really pointy sharp fins coming out from each side because the diagonal is what's on.
It's a straight line. Let me see if I can model it. Let's see. I don't know. Maybe we can model it, guys. Maybe we can model it. So window, 2 dimensions, equation, explicit. It's hard when you don't have a keyboard. You know what I mean? SQRT. X. Block interval. 0 to what? 0 to 4. Okay. Equation.
Yeah, it's like that, and then there's like a smaller triangle here.
Yes. And then there's
another smaller triangle.
Yeah. Do you get it?
Okay, sorry that I'm going real slow, guys.
Okay. So this is just one of the triangles, but like as they get smaller, they're like the one that's over here will get smaller. The one that's over here will get smaller because of that edge. Yeah. I think it's a rhombus.
Okay. Now let's see if I can do it. I want to. Sections.
I think the tears out of the mouth.
They don't have it.
This is actually like super cool. Like when he
Yeah, they don't have it here, guys. I mean, it kind of looks something like this, but not really. It's restricted. Yeah, it's flipped. But I think you guys know what I'm talking about. It's pointy. It's super pointy. It's coming out of the board, and there's points. So if you try to touch it, it's spiky on the top. Okay. So here we go. I know that this distance in blue is 2 square root of x. That's not going to help. Well, I guess it kind of helps me. How do I know that? Because it's this distance right here. And this is square root of x, and that's negative square root of x.
Oh, yeah.
It's just like the last one we just did. But instead, this square is not lying flat. Then, yeah, it's a 45, 45, 90. So, don't tell her nerd. Did you?
I said nurse.
Oh, I heard someone say nerd. Nerd. Sorry. I was backing you up, miss. I was getting ready to fight. Was that Bella? All right, guys. Sorry. The diagonal is on the XY plane. Are we clear?
Yeah. Wait, what does the XY plane mean?
It's two-dimensional. XY plane. Here's my x-axis. Here's my y-axis. So it's just by two-dimensional. That diagonal's on the XY plane.
Oh, okay.
All right, here we go. Help me out, guys. I need to find the length. So you guys already told me 45, 45, 90. N square root of 2. So that means, yeah. So in case you don't see what just happened, guys, we did this. N square root of 2 equals 2 square root of x. What you want is to find n, because we want the area of that cross section, right? Which is just n times n. So that means, let's see, divide by square root of 2, divide by square root of 2. So n equals 2 square root of x over square root of 2. So times square root of 2 over square root of 2, you get 2 square root of 2x over 2, so that cancels out. It's just square root of 2x.
Okay, no.
Unless I messed up. Okay, I'll start again. Maybe I messed up. Okay. Maybe I messed up. That's fine. So we know n square root of 2 equals 2 square root of x. Yes or no? Yes. Okay, I want to get n by itself. I divided by square root of 2, divided by square root of 2. So n equals 2 square root of x over square root of 2. But I got to rationalize it. So I multiplied this by square root of 2 over square root of 2. And I got 2. That's a radical and that's a radical. So I can put both of those inside a radical. Square root of law of exponents. 2x over 2. Those 2's cancel out. So I get that one of my sides for that square is square root of 2x. So my area formula is going to look different. So my area formula is parenthesis, square root of 2x, close it, square it. So it's just going to be 2x. Yes. Yes, you could do Pythagorean theorem and you get the same answer. But you got to call both lengths n, right? Because it's a square. So whatever you call it, if you call this a or s, like whatever you call this the same. So then s squared plus s squared, and then square root. Yeah, you can do Pythagorean theorem. You'll get the same answer. Does everyone okay with this one, guys? And we're gonna do one right now in a little bit together, so you can see how they're not that bad. Letter D. The cross sections are equilateral triangles with bases in the XY plane. Okay, that one we can. That one's pretty simple. So here we go. Here is the XY plane. And this cross section right here, this, guess let me color code it. This line right here in blue is this line right here in blue. And it's an equilateral triangle, so all three sides are the same. Oh. Do you remember how to find area of a triangle, of equilateral triangle, without using 30, 60, 90 triangle formulas. Oh man, you guys don't remember? From pre-cal? I failed as a pre-cal teacher. It is, but I don't want to figure out that perpendicular height. Oh man.
Oh, is it like an angle?
Yeah, as an angle. AB sine C.
Oh, I vaguely remember. No, I don't.
I remember.
Okay. I'll do it two ways, guys. I'll do it two ways. So this length in blue is 2 square root of x. Is everyone okay with that? So one way you could do it is you can go 2 square root of x times 2 square root of x, and then sine c, every single angle there is 60 degrees. Sine 60 degrees. So do you guys remember what sine 60 is? Pi over 3. So it would be 2 square root of 3 with the x on the outside, or 2x. Probably should rewrite it. 2x square root of 3. I'll show you another way. That's my a of x, but I'll show you another way in case you don't like it. If you remember, in a 30, 60, 90 triangle, you have n square root of 3, and 2n. You guys remember that? All right, if I cut it down the middle here, then half of this is just square root of x, and that's my short leg. So my long leg happens to be square root of x times square root of 3, well, it's going to be square root of 3x. Do you guys see that? So then to figure out the area of this triangle times 2, so it's going to be, well, I guess we don't have to do that. It's just going to be area of half base times height. So my base here is 2 square root of x, and then my height here is square root of 3x, and I'm dividing all that by 2. That 2 cancels out, and check it out. Square root of x times square root of x is x. So you get x square root of 3. Yeah, what happened? Base times height divided by 2. Did I mess up? That's square root of x. That's square root of 3 times square root of x.
Well, that's only half the triangle.
Times 2. Oh yeah, that's only half. That's just this triangle. Times 2. There it is. Oh no, because I put 2 square root of x there. 1/2 base. Let me start again. I confused myself. 1/2 base. The whole base is 2 square root of x times height, and the height is square root of 3x. Okay, we're done. So 1/2 base times height. 1/2 times 2. X square root of 3. Oh man, did I mess up over here? All right, hold on. A, B. Oh, I think I did that, no? I put the half here. 1/2 base times height. 1/2 base times height. Square root of x times. Okay, hold on, guys. Why isn't this one working? 2 square root of x times 2 square root of x. Sine 60 is square root of 3 over 2, right? 1/2 base 2 square root of x times height. Square root of x times square root of 3 is square root of 3x. Yeah. Oh, no, it's not. Man, I felt real bad today. 1/2 AB sine C. How come no one told me? 1/2 AB sine C. Now we're correct. The correct answer is x squared of 3. Okay, so let's take a quick note somewhere to correct ourselves. So to correct, area of a triangle, of any triangle, is 1/2 AB sine C. And I did not put that 1/2 in there.
Wait, and so that's an area of any.
Any triangle. Yes. You see this green right here? Or I guess now it's red. I use this property. N squared root of 3 and 2n. And so half of that is square root of x. So I need to take the square root of x and multiply it by square root of 3. So that becomes square root of 3x. Because of the properties of a 30, 60, 90 triangle. Does that make sense? X root 3.
Is the area of one of those cross sections.
Yes. All right, guys, we finally got the right answer, finally. Okay, here we go. This is from the 2008 AP exam. I think we are ready. I think. Look at letter A. You're going to need your calculator. And it says, let R be the region bounded by the graph y equals sine pi x and y equals x cubed minus 4x, as shown on the figure to the right. Find the area R. Do you guys want to see if you guys can tackle this one?
Is R the entire shaded part or just the?
R is the entire shaded part. Use your calculators, guys. X cubed minus 4x. What happened, miss?
Are you teaching?
Yes.
Oh, my bad.
Well, you're good. Ooh, I got a perfect number. I got a perfect number. We'll look at the rubric in a little bit, see if it's correct. Check your calculators to make sure that your mode is in radian mode. So in case you don't know how to do it, guys, here's a good time to start looking. We're finding the area under this curve. We're finding the area of this region. So what curve is on top? What curve is on bottom? The sine pi x is on top and the x cubed minus 4x is on the bottom. I like to draw a vertical line to see which one's which. So there it is, sine pi x minus, and I put in parentheses, x cubed minus 4x. I would just type those into y1 and y2. You're probably going to use them again. And then it's from 0 all the way to 2. And you can verify it that it's at 2 because at 2, both of them touch 0. Sine of 2 pi is 0, and 2 cubed is 8. 4 times 2 is 8. 8 minus 8 is also 0. So I know that both touch at 2 and both touch at 0. When I say both, I'm talking about both graphs. Yay or nay? Did everyone get a 4? Okay. Here we go to the next one. The horizontal line, y equals -2, splits the region R into 2 parts. Write, but do not evaluate, an integral expression for the area of the part R that is below this horizontal line. All right, so y equals -2. So let me go ahead and write that down. Do you guys want me to do this, or do you guys want to take a stab at it? All right, give it a shot. 0, 2.5. -4. No, not that one. Five, 3, 9, 1, 8, 8, 9. You have to use your calculator, guys. There's no way around this one. You must use your calculator. 1.6751,309. Okay, I'm gonna start it, guys. If you're pretty close to figuring it out, keep going. First thing you gotta do, I would type in y equals -2 into your calculator. Did you do that? Here's my y equals -2. Next thing you gotta do, I would look at the grid of this, and that's a grid I'm gonna put on my calculator. So I went to window and I put that grid. Doesn't have to be exact, but more or less around there. Are we in the clear there, guys?
What do you mean put in the grid? I don't.
Yeah, like x min, x max, x scale, y min, y max. I didn't put an equation. I just put numbers based off of this.
Oh.
See, I saw that it got to 2, so I went a little higher. I saw the max was 1, so I went a little higher. I saw the min was -3, so I went a little lower. You know what I mean? Then from there, I pushed graph, and I got this, which is perfect. So then, before you even start, guys, do you know what you're looking for? You are finding this area in blue. That's in between the curve and the line y equals -2. Are we in the clear? So you need to find those intersections. So how do I find the intersections? I tell the calculator, go second calculate number 5. And it's going to tell you, am I in this curve? Nope, I don't want that curve. Go to the next one. I want that curve, enter. And I want that curve, enter. Guess, go to the one you want. I just remembered I didn't save it to A, so I'm going to go to that. I go to that one, I push enter, and it has to say the word intersection. Did you guys get 0.5391889?
Yes.
Okay, save this to A. I like to go down the alphabet. I go to my home screen, I push X, and it's that same number. Do you guys see? I push STO, and I push alpha A. Oh, you don't want to round to the very end.
We're not evaluating.
Oh, you're not evaluating it?
No, it's like right when you don't evaluate.
Okay, then never mind. You don't have to save anything. Okay, do the same thing for B. So there it is. I got 1.6751,309. Did you guys get that? Or for the other X? So here it is. Integral from 0.5391889. I still prefer the letter A there, but that's fine. 1.6751,309. And then what do I put first? -2 minus what I put next. Close, and then I'm going to put a giant parenthesis like this. You can distribute, but be very careful if you do. If you don't like how it looks, you can say, no, I don't like that. Too many parentheses. You can distribute, just be very careful. And that's full credit right there. I wonder why they didn't. I bet you the calculator is going to work really hard if you try to do that. Maybe that's why. Oh, this curve in the top is on top. So it's this minus this that will get me this distance, right? Like that minus that will give me this, that. Like if I had a number line and this is at 8 and I had another point, -3, I want to know what this distance is. You always subtract. 8 minus a -3, 8, 9, 10, 11. That's 11. So it's the same thing, same concept. Okay. All right, letter C. Let's see if you guys just learned what, I know we just learned it really quick. Take 2 minutes, see if you guys can do it. All right, I haven't finished it yet, guys, but if you want to start looking up. So they want the volume of something that I have that's coming out, right? It says the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. So it's coming out of the board. I'd like to draw a line. This line here is just one side of that square, and it's coming out. So what curve is on top? Again, it's a sine. And then this curve on the bottom is now remember, there is a square. So whatever that distance is, I got to square it. So here it is. This is my cross section, and I squared it, and I'm going from 0 to 2. Whatever this will calculate, that is the volume. Hopefully you remember that you have sine pi x and y1 and x cubed minus 4x and y2. So don't make a mistake there, guys, trying to, so I would just let the calculator do all the work. Yeah, but we didn't square it. Don't square that number. It's not 4 squared. It's not 16. You need to go y1 minus y2 integral of that squared. So go, I bet you a lot of students did that mistake. Math 9, 0 to 2. And then parenthesis, alpha trace y1 minus alpha trace y2. Close it, square, and then put a dx on it. What do you guys get? Yeah, notice it is not 16. So do not ever, like, oh, we did it before with that number squared. No. 9 point, how many digits? At least 3. Can you always put more? Yes, if you want to put them all, put them all. 9.978. If you have a TI Inspire, you got to use the float. Use the float feature to get all your decimals. 9.978. I'm going to put more digits. 978344. All right. Letter D. And it's okay if we get this one wrong because we need experience, and we don't have that experience yet. The region R models the surface of a small pond. At all points R, at a distance x from the y-axis, the depth of the water is given by h of x equals 3 minus x. Find the volume of the water in the pond. Let's see if we can do that. Let's read it again. The region R models the surface of a small pond. So there's the surface. So you have a bird's eye view. You're looking at it from the bird's eye view. That's the surface of the water. At all points R, at a distance x from the y-axis. That's okay. So what it's saying is this, guys. Right here, you're 3 feet deep. Does that make sense to you guys? Let me put a black point. See that black point? At that black point, you're 3 feet deep. When I get here to x equals 1, you're 2 feet deep. Chavez, how are you getting that? 3 minus x. When I get to here at x equals 2, you're 1 feet deep. So it's a steady incline upwards. Do we see that? Okay, so it's kind of visually, it's kind of the same thing as what we just talked about, guys. Each of these cross sections, so think about it. Each of these cross sections is a what? It's not coming out of the pond this time. It's going inside the pond. Yeah. What type of what's the common shape? Not a triangle. It's a no. I think it's a rectangle. No. This length. It's a cross section. So look, I'm just doing this green. So this is 1. That's the length, and then the depth. Length and depth, length and depth. But the length and depth keep changing. Isn't the length and depth, if the length and depth keep changing, aren't those just rectangles? Yeah. I don't see a triangle because, oh, okay, maybe because you're thinking of the incline. The incline's a triangle, but I'm not talking about the incline. I'm just talking about like when I cut it. I'm not cutting the incline. I'm cutting the pool of water.
So this is the surface of the water, right?
Uh-huh.
It's like there's an incline here, right?
Yeah.
But then you're talking about these things?
I'm just talking about the water. I'm not cutting the incline.
Okay. So if this is the surface of the water, and then you have the incline going like this, whatever, away from the, so this is the y-axis here. You have an incline. You're talking about these are or these are squares here?
No, they're rectangles. Yeah, because this length is not going to be the same as the length of the depth.
Oh, okay. Yeah.
So they're different. They're different lengths. This distance, guys, from here, this distance in green is not going to be the same distance as the distance of the depth of that pool. So I just see a whole bunch of rectangles over and over again. It doesn't matter how I cut it. I see a rectangle, 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 rectangle. Now the rectangle is a different size, but it's the same it's the same shape. Yes. Do you guys see that? And I know it takes a lot of experience, guys, and we're asking a lot from you to be able to see that immediately without having a lot of experience. But yeah, so maybe we should, okay, you know what? We'll hold on to this one until we have more experience. Should we look at the rubric right now? Okay, let's try it. Okay,
So the water by the incline, it's just going to be super skinny rectangles, right?
well, they're all going to be skinny rectangles. They're all cross sections.
Yeah, but these are going to be like, instead of like this, with this, it's going to be super.
Well, these rectangles are going to be deep, but these rectangles are going to be shallow.
Yeah.
Yeah. All right, let's see if we can do it, guys. Area of a rectangle. A of x. How do I get area of a rectangle? Length times width. So one of the depthness is 3 minus x. And then the other, what is this length here? It's going to have to be upper minus lower. So that is sine pi x minus x cubed minus 4x. Okay, there it is. That's what I see as my area cross section. The region R models the surface of a small pond. All points are at a distance x from the y-axis. The depth of the water is given by 3 minus. Find the volume of the water in this pond. Yep. R is the distance x. Yep. That's what I see, guys. This I see as I'm going to put quote unquote here, guys. This I see as length. And this I see as depth. Yeah, you can, well, width. Yeah, length and width. And you're adding an infinite amount. Do they want us to find the volume?
Yes.
Volume. Tell me what I'm integrating from. From where to where? 0 to 2. Be very careful. This is the same as always. Y1 minus Y2. Do not, okay, on the, we're not teaching you the test. Do not type Y1 minus Y2, guys, because where do you see Y1, Y2 anywhere? You don't. I mean, I know some are tempted to, like, oh, let me write Y1 there, Y2 there. Don't give it new names. Leave it alone. They're calling them Y. So if they're calling them Y, they probably want you to write out the expression. Now, in your calculator, you can say Y1 minus Y2, but don't Don't write that down. Okay, here we go. 3 minus x, close, open, sine pi x minus x cubed minus 4x, close, close dx. And let's see what this gives us. I'm going to open it, and I'm going to go, yes, ma'am. Oh, they're not squares. It's a rectangle. Length times width, length times width, length times width. You know what I mean? If it were a square, I would square it because it's a square is side squared for a cross-section area. Math 9, 0 to 2. And I'm going to type in 3 minus x, close, open, alpha trace y1 minus alpha trace y2, close. I think I did everything correct. Push enter. 8.3699, is that what you guys got? 8.3699. All right, let's see how we did. What year was that? 2008. I haven't seen this key, guys, so this is fresh. I mean, I saw it last year, but I haven't seen it since. Calculus. Nope. College Board. Free response. AB. Scoring guidelines. 2008. Was it Form B or just 2008? Okay. Moment of truth, guys. I'm actually kind of nervous a little bit. Oh, it was the very first one. Look at that. All right. Letter A. Look how many points they gave you for letter A. They're being super generous when there's 3 points right off the bat. 3 points. One for, wow, they gave one for the limits on this one. One for the limits, 0 to 2. One for the integrand, sine pi x minus x cubed minus 4x. And one for the answer. Unfortunately, guys, some of the students, and it sucks, but I remember reading some of these and some that have trig. Some students don't reset their calculators and they're in degree mode. So, yeah. So if you were to be in degree, you would not get that 4, so you wouldn't get that point. What's up, miss? Oh, I thought you had a question. Letter B. How many points for letter B? 2. Oh, look, they did what I was going to do. That's fine. Lower limit 0.5391889. Upper limit 1.6751309. I'm taking a guess. Why did they choose R and S? Probably because they started with region R, so they just did little r, little s. I always like to go down the alphabet, little a, little b, but whatever. Did we get the point? Did we get the point for the integrand? Perfect. Letter C, did we get 9.978? So we got the point for the integrand, 1 for the answer. And here we go. Letter D is the one I'm most curious about. There it is. Length times width. Volume 0 to 2. Did we get 8.369 or 370? Why 370? In case they round it. Do you feel that we got, I mean, we're not professionals, but do you feel like we kind of got the concept down? All right, there's a Delta Math. Usually I would do the activity handout first, but the reason why I want you to do the Delta Math first is because they have visuals. Don't push, like once you get the question right, don't just push next, guys. I want you to click on the slider so you can see the volume, so you can actually see the shape of what is happening. Does that make sense? So yeah, take care of Delta, and that's it, guys. We'll call it a day. There's only 6 questions, so that's it. Finish 6 questions and done.